Hi everyone, thanks so much for your patience. We're going to go ahead and get started now. So thanks for joining us. As you know, we are going to be talking about the top 5 utilities for network engineers. So my name is Andrea Finch and I'm the marketing manager here at NetPiece. Just a few housekeeping items to take care of before we officially get started. If you miss any part of the webinar or you have to step out early, no worries. We're going to be sending out the slides and the recording. So just keep an eye out for that in your inbox today. And as you think of any questions, feel free to just send those over through the Q&A feature. I believe that is going to be on the bottom of your Zoom webinar, and we will get to any questions at the end of the webinar. So we're going to be covering 5 main tools today. They are going to be Nmap, TCP Dump, Netiquette, IPerf, Speedtest, and we'll also be demonstrating all of these utilities live on Linux. Now, Panos Vouzis is our COO and one of our co-founders here at NetPiece, and he's going to be leading the webinar. We're going to try to keep this to 30 minutes today. So, Panos, I will turn it over to you now.
Thank you, Andrea. And let's take a step back before diving into the technical details here and explain why a network engineer should learn Linux. Linux is intruding into the network engineering space. It's the operating system of choice to run applications and services, and we have seen the last few years that is finding its way into networking operating systems. This started a while back, back with open source projects such as OpenStack that has a networking component called Neutral. More recently, we have seen white label hardware and vendors using Linux as the core of their operating system. And to give a few examples, we can look at the OpenWRT project on the Wi-Fi side and vendors such as Cumulus, Arista, and Cisco, for example. And although CLI is not a stranger to network engineers, each vendor was siloed, and knowing the Cisco CLI didn't mean you knew the Juniper CLI. But now with everyone consolidating towards Linux as the base of their networking equipment, there is indeed an opportunity for anyone that has solid Linux skills. Current trends are pushing the skill set of the network engineer and the server administrator closer together. And with Linux, you can stay relevant, be more productive, and explore new avenues in troubleshooting. So I'm confident I convinced you to start learning Linux as soon as this webinar is over. But how can you do that? How can you get access to Linux box? There are many easy ways to do that. If you're a Mac user, you can open a terminal. It's a Linux-based terminal to begin with. On Windows 10, you can use an environment like Cygwin. And I was happily surprised last year to find out that Windows 10 supports Ubuntu Bash natively. So although Microsoft and Linux were polar opposites for many years, Microsoft stopped fighting Linux and embraced it for good reasons. Now, all cloud providers, Amazon, Azure, Google, have some kind of a free tier that most likely give access to one or a few free Linux servers on the cloud. And finally, if you want to set up your own Linux box, your own network, you can use a single board computer like the Raspberry Pi or Droid or BeagleBone. You may need to invest $50 to $100 there, or install Linux on an old laptop. So let's get started now with the first utility we'll be talking about today, which is Nmap. It's a 20-year-old utility since the latest stable version, and it stands for Network Mapper, and it's most often used for security scans. Fun fact, has appeared in around 20 movies, blockbusters like Matrix, Fantastic Four, and others like Snowden. So when you are watching any of these movies, pay attention and see if the presumably hacker there is doing something smart on the terminal. And at the very least, when you use Nmap, you can look smart among your colleagues, right? A very common use case is, as I said, to scan a host and find out details about specific machine. And let me show you how this looks like with an example. I have here my local Linux workstation, and I'm going to start with what we call a ping sweep. That's with the option -SP. And I'm going to scan my subnet here, okay, and see what Nmap can find for me. I'm going to give it a few seconds, and here it is. So it found a total of 11 hosts. As you can see, many Raspberry Pis here. It gives me the MAC addresses and other information if available. And that's the basic thing you can do. As you can imagine, if it's a very busy, a very, a big subnet with many hosts, that may take several seconds to complete. Now, let's say I want to dig a little bit deeper and see what's going on with specific hosts. So I'm going to target now my DHCP server here and see what Nmap can find for me. In 1.67 seconds, it told me which ports are open, its MAC address, and actually I can ask for Nmap to be a little bit more persistent and give me some more information with -O option. The trade-off here is that it takes more time, almost double the time, 3.85 seconds here. But it also told me, try to guess in some sense, from the information you can collect from the host, what operating system it's running, how many hops away it's from me. One hop in this case, we're in the same subnet, right? And this is just an example of a couple of options that Nmap has. When you wanna search and use a command in more detail, your friend is the manual of the command. So on any terminal, you can type man nmap and get all the information you need about a specific command. The last example I want to give here is how you can run a quick script here in one line bash script that allows you run nmap continuously. So the scenario here is that you have made a change in subnet, let's say in a network, right? And you want to scan and check before and after your changes if everything is okay, if all hosts are up and running after you made your changes. So let's say I'm done now and I want to keep scanning with Nmap my network to see if all hosts come up. So I did a while loop here, which is going to terminate when I hit Control-C, and every 5 seconds, it's going to sleep for 5 seconds and repeat the command again, right? As you can see here, I get the same results again and again. It's pretty consistent. But in your case, when you make the change, you might see hosts coming up after your changes and verifying at the very end that everything went okay or not. And okay, now I'm going to clear this and move on to the next one, which is TCP Dump. This is a bit older utility, and as the name says, it dumps TCP traffic packets on your terminal. A very close cousin is Wireshark. Wireshark has a very nice GUI and a command line version. You can use it to analyze pickup files and capture traffic as well. And of course, the common use case here is to trace traffic from a specific interface. And let's see how this looks like in action. The same terminal here. I'm going to start with the simplest, I would say, TCP dump command I can write. So I'm asking here to dump all the traffic it sees on interface ETH0. And this is what it looks like, right? As you can see, a bunch of packets coming in and out of my machine here. And actually, that's not too chatty here. Imagine a production server where you have many connections, lots of traffic. This would be like, like very busy. Text will be scrolling on your screen. So the very important thing with TCP dump is to know what you are looking for and find the right filters to get that information you want. So for example, let's say I want to repeat the same command, but filter only traffic that comes back and forth from host 30.10.202, right? So I use the host filter there. I type the IP of the host, and as you can see, I get only that information back and forth. So you can filter by host, by port, by destination. You can go down to the packet level, to the actually bits of a packet, and get only specific packets you are looking for. And as a last example of TCP dump, I'm going to show you how you can filter on specific port. So I'm going to use port 53. And right now, actually, you don't see anything going on. And that's because there is no DNS queries going on this machine, right? Port 53, of course, is the port that's being used for DNS queries. And I'm going to create one to show you how it looks like. So on the same machine here, I have a second window. I'm going to ping Amazon. So as soon as I run this ping test, I was going to create a DNS query to resolve Amazon.com and then start running the ping command. So I'm starting the ping test, and I see in my TCP dump window here the DNS queries, right? As you can see on this line, a packet left my machine and went to a Google DNS server and asked for the A record of Amazon.com. And then the Google DNS server responded with the IPs that belong to Amazon.com, right? So that's how it works. It gives you all this information. And sometimes when you're troubleshooting something, if everything else fails, you may need to go that low to the packet level, right? To the bit level of the packet to find out what's going on. And a very common use case is when you use a port as a span port on a switch, you connect your host there, and you mirror all traffic on that switch, and then you have to filter out which traffic do you want on which host, and exactly what kind of packets. Now, moving on to the next one, which is Netiquette. So Netiquette is called the Swiss Army knife for the network engineer. So it allows you to create connections between a source and destination, slice and dice it, UDP and TCP traffic. A gem I found in the, and I want to share with you, in the README file of the Netiquette, written by the author of Netiquette, of course, is if you're affiliated in any way with Microsoft Network, get a life, always key in control. So some solid life advice there, take it or leave it. And a common use case with Netiquette is to validate firewall policies. And let's see how this looks like. Now, I'm going to need here two hosts, a source and destination. I'm going to open this one and this one, right? So, two different machines. And I'm going to start by starting a server on the machine on the right-hand side by using Netiquette and listening on port with the -L option and -P 20,000 here. So, I'm starting here a server waiting for traffic on that specific port. Now, on the left-hand side, I'm gonna connect to that server waiting for my traffic on port 20,000, okay? Connection established. You don't see anything right now, but whatever I type here, it's gonna appear on the right-hand side. Simply straightforward, very similar to Telnet. I would say there are some differences between Telnet and Netiquette, but with Netiquette, you can do so many other things. Again, there are dozens of options that you can use on Netiquette for whatever you're trying to simulate or test. And again, the use case here that if you want to test a firewall, you can set up a Netiquette server behind the firewall, waiting for traffic, and then try to connect to that server from outside the firewall. And depending on if you are trying to block the traffic or allow the traffic, you can test if your firewall works properly or not. Now, the last thing I want to show you with Netiquette, something I use often, is to upload files to a log server. And the way this works is that you set up, again, a Netiquette server on a specific port, but now instead of redirecting your output of the Netiquette command to your terminal, you're redirecting it to a file. So whatever comes to that server is going to be sent to file webinar.log with a redirection symbol. So now this server there is waiting for traffic. And on this side here, I'm going to create a dummy, let's say, file here. I'm going to name it again webinar.log. Okay, that's all that there's in the file. And now I'm going to use Netiquette again to send this file to the log server waiting for the traffic. But again, instead of sending input to Netiquette from the terminal, I'm going to send whatever is in this file, right? So I'm going to hit enter here. Of course, it was instant. The file has been transferred to the log server here. And actually, by using cat, I can see that the file was sent properly. Of course, just to make a parenthesis here, the traffic is not encrypted by any means here. It's not compressed or anything, although you can compress traffic on the fly with Netiquette if you want, if you have a large file. And there are many other ways to send files between servers, but for a quick and easy way to send files between servers, Netiquette can be your friend. Let's go to the next one, which is IPerf. So there are two versions of IPerf out there. IPerf 2 is the older version out of 2003, and IPerf 3, I think it's 2 or 3 years old. The first stable release was released a few years ago. Keep in mind that they're not compatible to each other, so you have to use either IPerf 2 or IPerf 3. And there are also, I know that there are what's called JPerf, Java-based IPerf, which is a nice GUI interface if you want to use IPerf to test connections on your, on a GUI on your laptop. So perf stands for performance here, and what IPerf does is that it sends traffic between a source and destination, and you pretty much test if you can pass a certain amount of traffic. The common use case that I have seen here is to prove that it's not the network. As simple as it sounds, it's something that I think everybody should start from when they're troubleshooting something. And IPerf helps because you can test your, I would say, the very low level, if you can pass a certain amount of traffic and take out of your troubleshooting list the actual connection of the network. Let's see how this looks like in action. I'm gonna gain again 2 servers here. I'm gonna clear this one and clear this one. And I'm gonna start on the right-hand side what we call an IPerf server with a -S option. And the -I1 option just gives me a little bit more logging information. And now on this side, I'm gonna connect to that IPerf server waiting for my traffic with what we call an IPerf client. And I'm gonna, of course, use the IP and again use the -I1 flag to get logs every 1 second. So connection established, I'm getting up to 940 megabps here, close to 1 gigabps. These are 2 machines on the same switch, so things are pretty ideal here. I'm almost saturating the link, right? And I can show you also how the UDP looks like. For the UDP IPerf, you use the -U flag. And now on the client side, I use the -U flag. And actually with the UDP, you can also set the amount of traffic you want to push. Let's say 10 megabps here. And of course, this gets delivered without any problems. You can see the logs on both sides. And at the end, I'm going to see the summary. And with UDP, I'm also getting the jitter, 0.013 milliseconds, almost 0 here, and 0 packet loss. I wouldn't expect anything worse on this setup, again, with 2 machines on the same switch. Keep in mind that with IPerf, when you run an IPerf test, you push actual traffic into your network, right? So you don't want to run IPerf too often, or when you run it, keep in mind that you might be affecting actual useful traffic on your network with your test traffic. So use it with caution. You can use it during testing your circuit after your installation to make sure that everything is there. Or again, during troubleshooting to make sure that you can pass a certain amount of traffic. And the last one is Speedtest. So this is the Ookla Speedtest.net that you know of, that you can run on your browser. So Ookla has around close to 5,000 servers geographically dispersed around the world. They're maintained, some of them by Ookla, some of them by volunteer organizations. And the difference here between Speedtest and IPerf is that when you run an IPerf test, you have control of the server, of the client. You know what's in between them, especially if it's a one network. So there are less variables and uncertainties when you run a test there. Now with Speedtest, you run a performance test against an internet-based server that you don't control. You don't know if somebody else is running a test against the same server at the same time. You don't know what's in between you and the server. So often Speedtest gets abused by users. We always advise use Speedtest with some caution because you might be paying for, let's say, 50 down and 10 up to your ISP, and you're running an IPerf I'm sorry, speedtest.net on your browser, you're getting 25 and 5, and you go and complain, hey, why am I not getting what I'm expecting? So because there are so many variables and uncertainties there, right? So it's a good test to know about and use, but again, use with caution. And here, I would say the use case to prove it is that it's not the internet, because it's a speed test towards the internet mainly. And I can show you how this looks like. It's very simple. You just type the command speedtest CLI, and I can show you actually in our follow-up emails after the webinar, we'll have information on how to download and install all these utilities on your Linux box. So I see here that Speedtest detected a close-by server maintained by speedtest.net. It's in San Jose. That's where I'm located right now, with 28.8 milliseconds of latency. And now it's running the download speed. It's going to give me probably something close to 50 and 60 megabps. Okay, that's what I've been getting in the last, constantly here. So the important thing with speed test is that you have to look for discrepancies. You can see, if my performance dropped from 50 to half of that, right, after a certain point of time, that may mean something, right? And my upload speed is 5.6, not that good, I would say. So, in closing the technical part of the webinar, I wanted to show you how this ties with NetPiece. So in a nutshell, NetPiece is a network monitoring solution that helps you capture user experience, and we do that by installing sensors around your network. So we'll let you install a sensor, hardware, software, and that sensor now acts as a user that runs active monitoring tests towards the internet, towards services, or IPerf test or speed test between that location and, let's say, an IPerf server that you control or a Nucleus server. And as an example here, since each one of these agents is a Linux box, we also give you console access here, right? So you can have a bunch of NetPiece agents, and with a couple of clicks, you can get access here to the console. Now, what happens is that when you get that access, the convenience is that you don't have to manage these one by one, right? If you had to access all these Linux boxes through SSH, through a connection for each one, it would be very messy, very cumbersome. We'll give you a single pane of glass, and you can give you console access to all these machines. And that's an example. Let's say I'm on this machine here, and I want to run an nmap on this host, right? And actually, let's use the simple one, nmap, right? So you get here the same command you get on your console. Again, it's a very easy and convenient way to get access and do some troubleshooting commands. And the additional benefit, of course, is that for tests like IPerf and Speedtest that you can run manually on the console, here you can do them on a continuous basis, on a periodic basis, on a schedule, get historical averages, alerts. This is an IPerf, for example, between our Pittsburgh and San Jose offices at 5 megabps. That gives me also jitter and packet loss. And I can see here a speed test that is running from 2 agents in Beaver, Pennsylvania, and Etna. Again, with historical information around this test, right? Without having to do it manually on a console. And with that, I will pass it to Andrea for the Q&A. Andrea?
Okay, great. So we are going to move to the Q&A portion of this now. Again, that's going to be a feature on the bottom of your Zoom webinar, so just feel free to type in any questions there. I'll give you a minute on that. While we wait, just wanted to let you know that you can actually request a free NetPiece account on our website. So that dashboard that Panos was just going over, you can actually get free access to your own. If you just go to netpiece.net/free. And if you have a Raspberry Pi at home or at work, you can use that as an endpoint and then connect it to the free dashboard and get end user monitoring that way. So NetPiece is usually offered as a monthly or annual subscription. So the free option is kind of a cool way to just kind of try it out and play around with it first. Okay, so let's move on to some questions. So Panos, the first question here is, how can you filter ICMP traffic on TCP Dump?
Okay, great. So I can show you actually that on a live. I'm gonna open the same host here and type the TCP dump command. I'm gonna use as interface any, meaning that I'm gonna capture traffic from any interface here. And now the filter is just ICMP, it's as simple as that. It's a very common filter that is used on TCP dump, so they made it available there. I'm gonna hit enter, and actually, I won't see any, actually I'm seeing any traffic because I'm running the ping test I started earlier towards Amazon.com, and I can see only the ICMP traffic that I want here without anything else. Good question, thank you.
Okay, and the next one is, what are the limiting factors of the IPerf performance?
Sure, great question as well. Of course, one limiting factor is the circuit, the network between the source and destination. The example I gave you earlier, I had two hosts running connected on a gigabit switch, right? So they could get up to 1 gigabit of TCP IPerf there. Now, in the case that they were connected on a 10-100 switch, then of course the maximum performance that could be achieved there would be 100 megabps. And that's about the network. Now, there are other factors. For example, pushing that traffic, creating that traffic on a specific host to push it over the network needs some CPU, of course, power. And if your machine is not beefy, not strong enough to create 1 gigabps of traffic, for example, you might not get that high. And the memory of the machine is an important thing, and also the latency between the two hosts, right? So the larger the latency, TCP performance suffers, and you might need to adjust there things like the window size of the TCP connection to get better performance. It's a multi-factor, I would say, performance test, and there are many parameters actually on IPerf you can use and adjust depending on what network you are at and what machine you are running it on.
Okay, great. And it actually looks like that's it for questions. Again, we are going to be sending out this presentation, so if you happen to think of any questions later, feel free to just reply to that message, and we'll happy to get anything else answered for you. So that's going to be it for us today. Thank you so much. We hope to see you in a future NetPiece webinar, and enjoy the rest of your day.